Quiz 6.2 Geometric and Algebraic Vectors. In this playlist, I have given you a set of 25 questions right in the very beginning. And in the second half, I am giving you the solutions for these problems. Here is the solution for question 3. Question 3 is, the diagonals of a parallelogram ABCD meet at the point E. Show that AE, EB, EC and ED equals to 0. Now the strategy here is first sketch your diagram, right? So first sketch, always sketch. So let's make a parallelogram. So that's kind of a parallelogram, right? I'm sure you can make much better than this, but this rough sketches of mine will definitely help you to understand the concept, right? So I'm not trying to impress you with my drawing, but I'm trying to give you a concept here, and I hope you appreciate. Now let's join these diagonals. So the idea of joining the diagonals is because we have diagonals of a parallelogram ABCD meet at a point E. So let's figure out where the point E is, right? So I'm drawing this dotted purposely. So these are my two diagrams. And let's label it. This A, B, it should be in order, A, B, C, D, right? Always in order. And E is your point of intersection of these diagonals. Now to answer the question, you should know properties of parallelogram, right? So we know that we have two pairs of sides here, which are parallel and equal, right? So these two pairs are actually parallel and they are equal. So that is to say that vector AB is equals to vector DC, right? And we also know that the diagonals bisect. So these diagonals also bisect. So point E actually is the midpoint of this parallelogram. So that's the property of parallelogram, correct? You can prove it very easily. If there are two parallel lines and we have a transverse line, then we know that these angles are opposite and alternate angles are equal, correct? And we also have this opposite sides equal, so we can have these two alternate angles equal, and this is equal to this angle. These are alternate angles, and we know these sides in a parallelogram are parallel and equal. So from angle, side angle, we know they are congruent, and since they are congruent, this side is equal to that, their corresponding sides are equal, right? So we know E is the midpoint. Now this is just to give you a brush up for those who really want a proof for everything, right? Now when we say that they are equal, then we also say that vector AE is equal to vector EC, right? So we know in this case that vector AE is equal to vector EC. Correct? Now, when we are trying to make something zero, we are looking for vectors which are in the opposite direction, right? So EC could be written as minus of CE also. Is it okay? E to C is minus of C to E. Because when we reverse the direction, it becomes negative, right? That is how we get opposite vectors. And these are equal and opposite vectors. So if you add these two vectors, it becomes 0, right? So A to E and C to E, right? So since you know CE will be same as EA, I could actually write this as minus of EA. Is that okay? So CE is same as EA. And now since AE and minus EA are equal, then we know if we add these two, then we get 0 vector, correct? EA minus EA, right? I mean AE, and then we take away EA from it, right? Minus EA. So that becomes 0, right? Now, so that is the concept. which we are going to apply here to solve the problem. So what we will do here is, we have EA, so we are having all this set of vectors starting from E going outwards, right? So ED, now let me write this again. So we have EA plus EB plus EC plus ED. We need to prove this to be 0, right? Now EA can be written as minus AE. Is that okay? EA could be written as minus AE, right? So minus of AE. Now EB could be written as minus of BE, right? Minus of B, correct? I'm just flipping this, saying that they are equal, right? So EC, E to C. So we'll keep E to C as such. We have already reversed two vectors, right? And when we add those reverse vectors, the opposite vectors will get 0. So we have plus EC plus ED, right? What we did was we reversed and wrote with the negative sign. We wrote opposite vectors for two of our vectors out of these 4. Now look at it. So we have AE, A to E, and then E to C, but A is minus. So if you combine these two and you combine these two, what do you get? Let's have a look. So we have EC, so E to C. Let me draw a bar on the top. Because normally when we type in, we can make them bold. When we write, this bar indicates a vector. So EC minus AE. And here we have ED minus BE. Okay? So this is our proof for the given statement. So EC is pointing this direction, EC. Minus AE, minus A to E, right? Now, AE is equal to EC, right? They are same magnitude, same direction, and therefore this is 0. Is it okay? Because AE is same as EC, correct? So it is 0. Similarly, look at the other side. E to D. E to D is going in this direction, E to D, and B to E, B to E. E to D and B to E are equal. So when you subtract two equal vectors, what do you get? You get a 0, correct? So subtracting equal vectors, you get 0. So we get 0 vector. Do you see that? So that is how we can show that the diagonals of a parallelogram ABCD which meet at a point E, then these sums right from EA to EB to EC to ED is equal to 0, right? Or a 0 vector. Now what is a 0 vector? 0 vector has a magnitude of 0 but undefined direction. Remember that part. Let me summarize 0 vector. Part of learning. So magnitude is 0 and direction undefined. And let me write undefined direction. Right? So any problem where you have a parallelogram, what you have to show is that all these sides are equal, and therefore we have set of equal vectors, right, in a parallelogram. Sometimes the question can be asked, write down 2 or 3 sets of equal vectors in a parallelogram. So you can do this, right? And then you can try to prove it in this fashion. right? Another alternate proof could be that you could write one particular vector as combination of other two. For example, EA, right? So EA could be written as combination of ED plus DA. And EC could be written combination of EB plus BC. And then you can combine all these things, and you'll get 0 as the sum. So that's an alternate method which you can try to prove this, right? So there are many ways to solve the problem. I'll appreciate that you try to solve it in a different way. That'll be good for you. Thanks and all the best.